I can call it. Let me take a screenshot of this question. Then you go to Excel to work there. You will tell me if you can see my screen. If you not be seeing my screen Excel file, you will also notify me before I continue. Okay, I think the screen has come. Okay, if you cannot see the screen, please let me know. All right, so this is an example we have now. So to answer this question, we have how many years. You see, we need to determine when the asset should be replaced. That is a requirement. So let's determine how many cycles, okay? The number of cycles, our N is 4 years. So if it is 4 years, it implies that we have to look for 4 cycles. So we have four cycles, 4 cycles. So let's start on, we can start on fourth cycle, go to third cycle, second cycle, and first cycle. Or we can go with the first cycle, second, third, and fourth. Whatever we want, we can go through that. Okay? We can start on whatever cycle. But let's start on first cycle, and we can go like that. First cycle. It means it is the first year. Let's consider all the cost and all the benefits. Okay? All the, let me call it, okay, let me admit here somebody. But please, the people have not joined the array. They are disturbing us. You see, they are disturbing us. So please, what I'm saying is, on the first cycle, this is the first year. We want to consider all the cost and all the cash outflow in inflows, the relevant ones. Okay, then we consider them. So now we can have year 0, year 1. Okay, that is first cycle. It means year 0, year 1. So here we'll be putting my items. Here I'm making cash flow analysis. Okay, you know, this is the cash flow analysis. If I can say, here we're going to put these are years. So we're going to say now we have a maintenance cost. Okay, maintenance cost. What are they? Our maintenance cost in the first year, it is 5 million. Okay, these are 5 million. And you know, purchase cost is also relevant. Purchase cost of this machine, you will also purchase it in by 50 million. So you can put here initial investment or purchase cost, or the initial investment. These are the same. We're putting 50 million. Those are 50 million outflow, and this maintenance cost is an outflow, remember. And we also have residual value. Residual value, it is an inflow. Yes, it is an inflow of how much? Residual value in year 1, it is 30 million. You know, I know some student might make a mistake and say, why should we didn't consider year 2? The figures in year 2, 25, and this 10. No. We are considering first cycle. Turi nko gutomboza tukareba ese turi perezida mwaka wa mbere ni ibiki byabo. Urumva umwaka wa kabiri ntabwo turi concerned nawo, wa gatatu ntabwo turi concerned nawo, wa kane ntabwo turi concerned nawo. We are also concerned with only this the cost and also the inflows, cash outflows and inflows in year 1. So now we can have our net cash flows. Net cash flows will be this. Okay, it will be this. This is it. This is our net cash flows. And we are going also to discount them. Present value interest factor, at which cost 10%. So we have year 0, it will be 1 plus 10% power 0, which becomes 1. You know, you can do like this. That is 10%. So I put power 0. That is 1. And I told you you have to keep at least three figures after decimal. I see here somebody is also wanting to join. They may admit. So the people who are eating our time for nothing. So maybe I will rate Sepe some time, um, give them the right to be admitting the people. 1 minute, 1 minute. Okay, now I'm saying on then present value of our cash flows. Present value of our cash flows is equal to how much? It will be this 5 million. So I'm going to, I see also another people wants to join us. So let me admit Benjamin. All right. Then let's do cash flows. So any PV on your, please, somebody, you need to mute yourself. Please mute yourself. Please, please. Okay. So now, when you look at our things now, this is our NPV of cost. You see it is negative. Say NPV of cost or present value of cost that will be incurring in year, in the first cycle or in the first year. Then let's look at the second cycle. Second cycle. So we can do the same, but we'll be having second year. We can say here that's the first year and the second year here to be considered. So now I can say we have all the cost. We have maintenance cost. The cost we'll be using to maintain the asset or to maintain our asset. Okay. So the cost that we are supposed to be using, when you look at this, all right, when you look at this, you see we are supposed to deal with maintenance cost in year one. It is 5 million, 10 million in year two. Let me write it here. 5 million, and here it is 10 million. So let me put comma. If you have a question, please, you can unmute yourself and ask me a question. Don't worry. You can unmute yourself and ask a question. Then residual value. Residual value. Actually, you see what we are dealing with is the maintenance cost and the residual value because it's the cash inflow and outflow we have in this question only. So, but the residual value here in the second cycle, it will be the value of the second year, not of the first year. Because of the one of the first year, we are not concerned with because we will not replace in the first year, we will replace in the second year. That's what we are trying now. Okay. And the second year it is in the second year it is 25. 25. Okay, you can put here 25. It is cash inflow. Residual value, it is a cash inflow. Then purchase cost, we have purchase cost. The purchase cost, how much? It is 50 million. 50 million. This is 50 million. Then we can have a net cash flow. Net cash flows, which is going to be summation of all of these figures. That is summation of it. So this is our net cash flows. Now let's determine present value interest factor. To discount it, let's discount it, present value interest factor at 10%. So on year zero, it is plus 10%, then power negative this year. Okay. Let's use the 3 decimals after a point. So now PV of the cash flows, PV of cash flows, present value, it is this 50 times our present value interest factor or our discounting factor. You see, I will be having this figure. So let me determine any PV of cost. Okay, if we replace in second year, what will be the cost? Any PV, you know, I will add all of this. This is NPV for the second cycle. That is NPV for the second cycle. For the second cycle. Now, let's determine, all right. So now let's determine the third cycle and the fourth cycle. Third cycle. So let me have like this. I know I need it. So let me have here 3 here. I hope you are writing. Okay. Of course, I'll give you the Excel file, but you need to write, because if you write, that is when you understand it more. Okay. If you write, that is when you understand. I believe in that. So, okay, you should be writing. So now we have a maintenance cost of how much? Look at year 3. Year 1, it is 5 million, 10 million, and 16 in year 3. It is a 5. You can say here 5 million, and here 10 million maintenance cost, and here it is 16. Yes, 16 million on year 3. 16 million. That is on year 3. So residual value, we consider residual value of year 3 only, not year 1 and year 2, because year 1 and year 2, we are not concerned about that. We are concerned if we replace in year 3, what should be our cash flows to be considered. All right. Now, let's look at residual value of year 3. It is 18 million. That is here what we put there. It is 18 million. Sorry. This is 18 million. Then the purchase cost, it is 50 million. Outflow. So the net cash flow will be the summation of this. The summation of these 50 million of these figures in or years. So we have a present value interest factor will be 1 plus 10%. Okay. Then power negative this year. Negative n. It will be negative n. This is the answer, the figures. So we can multiply our net cash flows with the discounting factor. So if we multiply it, we have these figures, then we can have NPV of cost, okay, which is a summation of all of these. Okay, it is a summation of this, which is 61. This is 61,000. Okay, this is our NPV of cost. Please note this. This is the present value of these cycles. Okay, now let's try the last cycle, which is fourth cycle. Fourth cycle. So we are going to discuss with or to deal with another year, fourth year or fourth cycle, which will be okay. Here we remove this, but we can add only the maintenance cost of here. It is 20 million. Maintenance cost of fourth year, it is 20 million. Okay, I have to give it a negative sign because the unit is an outflow. All right, it is an outflow. It is an outflow. So let's determine also the residual value of it at the end of year 4. Residual value of the machine will be 12,000. So 12 million. 12 million. This is our 12 million. So nothing will be having as an investment here, but we're going to add this cost as well. So we have 80 million remaining. So we can have discounting factor for year 4. Then if we multiply, we're going to have these figures. Okay, this is for year 1. For maintenance cost for year 1, year 2, year 3, year 4. Then the residual value for year 1, residual value for year 1, residual value for year 4 only. That's what we should consider. And the purchase cost, as you have seen. Now, the net present value, NPV, it is going to be now 80 million. 80 million. So we cannot choose like here and now. We need to determine equivalent annual cost. That is step 2. Remember in our note, I said determine equivalent annual cost. So let me come here and determine. This is step 1, is determine the present value of each cycle, NPV of each cycle. Then let's determine ESC, equivalent annual cost. It's not East African community. This is equivalent annual cost. Okay. Not say it is a East African community. This is equivalent annual cost. So we're going to have now, okay, there we're going to have a cycle, our cycle, remember, or a period, then put years or a period. Then we can have a NPV of cost. If you remember, our NPV we determined, and also we'll be putting PV FAR. You know, PV FAR, this is a present value factor of an annuity, okay? Remember, 10%. So, and you have also equivalent annual cost, ESC. How do we determine ESC? We said you take any PV over present value factor of an annuity. Okay, PV FAR of annuity. This is year 1, year 2, year 3, year 4. Those are the 4 cycles, if you remember. We had 4 cycles. And then any PV, of course, we have determined it here. Let me take it. This is it, number 1. Number 2, it is here for the second cycle. Number 3 is this. Number 3 is this. Then number 4, it will be this 80. So now let's determine our present value interest factor of an annuity, okay? Present value interest factor of annuity. Let me do like this. Present value interest factor of an annuity, okay? You know what will happen there? We said 1 minus 1 plus rate, okay? Plus rate 10% power negative n, okay? Then what we get, we divide, okay, by r. Remember our r is 10%, okay? That's what we'll be doing. So let me put this one to avoid the confusion in calculation. Divided by 10%. This is our answer for the first year. This is for the second, for the third, and the fourth. First year, second year, third year, fourth year, like that, like that, like that. So equivalent annual cost, it's about any PV over PV FAR, okay? Then we get our equivalent annual cost. Our equivalent annual cost, okay? If the figure is positive, it is not equivalent annual cost, it's equivalent annual income or annual value. Okay, then this is our solution. Now let's choose where are we minimizing the cost. You know, it is a negative, we need to minimize. If it is negative, we have to choose the less. If it is a positive, we have to choose the highest. But here it is a negative, it is a cost. We need to minimize the cost. Where are we minimizing the cost? Here we have 25, we have 24.6, 24.2, 30 million. So it means year 2, it will be the year where we'll be having a maximum number, where we'll be maximizing or minimizing the cost, which means that when they say advise on the when the asset should be replaced, and when you look at this, you see the asset should be replaced in the second year, or in year 2. So we can say our advice, okay, based on the calculation, remember our advice is the asset should be replaced in year 2. Okay, that is our advice. So you base on this calculation or on this computation. Okay, then I hope everybody knows this, what I have computed. Now let's go to another question. Okay, you know, our class today is about questions. If you have a question, please let me know. If you don't have a question, it's okay. Now let's come to our note. Yes, Dolin, you can ask. Yes, unmute yourself and ask me a question.
I need you to come back on the fourth cycle.
On the fourth cycle, okay, let me present